Okay, let's add a small twist to this, not a big deal. To get this cosine of x by itself, I subtract 1 from both sides. And a half minus 1 is negative a half. Cosine is negative in the second and third quadrant where x is negative. So if x is 1 and the hypotenuse is 2, this is that bigger angle, that 60-degree angle. So that's like 2 pi over 3. 3 pi over 3, that's 1 pi. And this one is 4 pi over 3. That must be the two angles in the second and third quadrants. And then plus 2 pi k. Now, we're going to call that answer the general answer. General meaning all the solutions. Now, though, this is not general anymore. This is specific. So I want to be between 0 and 2 pi. Well, here's where this k is going to come in. So watch. Here's the first answer. Here's the second answer. Now k is an integer. Positive and negative whole numbers. So whole number, I start with 0, I plug in 0, wipes this out, and I get 2 pi over 3. If I plug in 1, this is 2 pi plus something. Did you hear that? 2 pi plus something. Well, if my biggest answer is just 2 pi, if I add something to it, it's too big. Let's try it again for this answer. Again, k is an integer. 0 is an integer. I plug in 0 here, wipes this out, and I get 4 pi over 3. Well, 6 pi over 3 is 2 pi, so 4 pi over 3 is in that general area. That's fine. But if I plug 1 in here, then this becomes 2 pi, and 2 pi plus anything is bigger than 2 pi. So that's going to be 10 pi over 3 if I add 6 pi over 3 to 4 pi over 3, and that's too big. So then I don't have this answer, don't have this answer, I just have these two. Now let's go crazy. Okay? Now, could we say that 2 pi is the same as, look at these denominators, 6 pi over 3. You see the 6 over 3, which makes it 2. And 4 pi is the same as 12 pi over 3. Do you see 12 over 3 makes our 4? So we're going to keep that in mind to see if my answers are between these two numbers. So I take the same general answer. If it's general, it works for everything. In the second general answer, I plug in 0, I get 2 pi over 3. Well, that's too small. I plug in 1, which is an integer, and 1 is like, plug in here, becomes 2 pi. Another name for 2 pi is 6 pi over 3, plus 2 pi over 3 is 8 pi over 3, and 8 pi over 3 is between 6 and 12, so that one's okay. The next integer is 2. I plug in 2, and if I plug in 2 here, I get 4 pi, and 4 pi is 12 pi over 3, and here we go again. 12 pi over 3 is the biggest I can have. If I add anything, it's going to be too big. Add 12 pi over 3 plus 2 pi over 3, that's where I get the 14, but I already knew from once I was adding to the 12 pi over 3, it's going to be too big. Same thing for this one. I plug in 0. This one is too small. I plug in 1. Well, that's 1. 2 pi is like 6 pi over 3. 6 plus 4 is 10 pi over 3. That's okay. But if I plug in k is 2, well, 2 times 2 pi is 4 pi, and 4 pi plus anything is too big. It becomes 16 pi over 3 if you care. but we can tell it's going to be too big. So these are our two answers in this interval. So let's get the sign by itself. Divide both sides by 2. Sign is positive in the first and second quadrants where y is positive. Oh, there's our root 2. We know it's going to be a 45-degree angle in the first and second quadrant. 1 pi over 4, 2 pi over 4, 3 pi over 4. And just to check, 4 pi over 4 is pi. That gets us to this 180 degree to make sure we're using the right numbers. So there's the pi over 4, and there's a 3 pi over 4. And we're just solving for theta, so we don't do anything special. But for our general answer, our general solution, we have to get all of them. So we add 2 pi k. K is an integer. We take our general answers, put them here and here. But now they want a specific answer. Well, at k equals 0, I get pi over 4. That's in here. And over 4, let's see, 0, and isn't that 8 pi over 4? That's the same as 2 pi, isn't it? If I let k equal 1, that's 1. 2 pi plus. Well, right now we know 2 pi plus anything is going to be too big. But if you want to keep going, it's 8 pi plus 1 more pi, or 9 pi. I hope you can see we don't have to do that. The same thing is true here. You plug in 0 here, gone, and we get 3 pi over 4. You plug in 1, well, that's 2 pi already, plus anything is too big. Doing the math, it's 11 pi over 4, but I hope you can see it's not going to work. Now we're going to change it to between negative pi over 2, or negative 2 pi, and 0. So I plug in 0, like I did earlier, I get pi over 4, but that's too big now, because we want negative answers. So I think I'm going to plug in negative 1. That's also an integer, right? Positive or negative whole numbers. Okay, let's see, over 4. So this is negative 8, actually negative 16 pi over 4, right? No. What am I doing? I was right the first time. So negative 8 pi over 4 is negative 2 pi, right? So then I plug in negative 1 and negative. If I plug in negative 1 here, that's going to be negative 8 pi over 4 plus 1 pi over 4. That's going to be negative 7 pi over 4. And that's in here. But if I plug in negative 2, it's going to be negative 15 pi over 4, and that's too small. It's too negative. Do the same thing here. Plug in 0. I get 3 pi over 4, but that's too big. I need a negative answer. I should have known that all along, but I wanted to start there. Plug in negative 1 here. I have negative 2 pi, which is negative 8 pi over 4. You see the negative 2 pi there? Plus 3 pi over 4. Well, negative 8 plus 3 is negative 5 pi over 4. And that's just right. Sounds like Goldilocks, huh? Too big, too small, just right. If I plug in negative 2 here, I get negative 4 pi, which is already going to be past this, and it's going to be too small. So these are the two answers I want for this restriction. And now they're going to make it even stricter. So I look at these answers that I have here, and this one is between negative 2 pi, or negative pi over 2 and positive pi over 2. And all the rest of these answers are not in here. After I plug in 1, -1, this is too big, this is too big, this is too big, this is too small. And so as it turns out, this is the only one that fits in that interval. But these tables help me to see what numbers work.